Today we're going to talk about describing distributions numerically. First thing we're going to talk about is center. There are three types of center that we're going to discuss. The first one's called the median. And you'll notice the notation x with a tilde on top of it. The median is the middle number of the data that has been placed in ascending order. Take the following data. First thing we need to do is put it in ascending order, from lowest to highest. Then what we're going to do is look for the middle number. Now, the middle number is that first 5. You'll see that we have 4 numbers to the left of the 5 and 4 numbers to the right of the 5. However, if we have an even number of data, and after putting it in ascending order, you'll notice we have 2 middle numbers. So to determine the median, what we need to do is find the average of these 2 numbers. So we're going to add them up, divide by 2, and we get 4.5 as the median. The next center that we're going to talk about is called the mean. And the notation for this is x bar. And it is the average. In other words, you're going to add up the data and then divide by the number of the data. So here's our data again. And what we're going to do is we're going to add them up. And since there's 9 pieces of data, we're going to divide by 9 and we get 4.667. So the formula for x bar is the sum of the x's divided by n being the sample size. Next we're going to talk about mode, and it is the most frequent number in your data. So again, taking our data, we don't have to put it in ascending order, we're just going to look for the most frequent number. Since there are 2 5s and 2 8s, we have 2 modes, also known as bimodal. So 5 and 8 are our modes. Next we're going to talk about spread. Previously we talked about spread in terms of range, and range is max minus the min. So we're going to look for the highest and the lowest values. So the max is 8 and the min is 1, therefore the range is 7. The next thing we're going to talk about in terms of spread is called the interquartile range. The data is placed in ascending order and then it is split into quartiles. So we take our data, put it in ascending order. Now we already know the middle number is called the median. It is also called the second quartile. Now we're going to take the lower half of the data and find the middle number, and we're going to take the upper half of the data and find the middle number. So 3 and 6 are our first and third quartiles. So you'll notice at the lower half we included the first 5. So we have 1, 2, 3, 4, and 5. So we have 5 pieces of data, and we take the middle one, which is the 3. For the upper half, we have the 2 5s, the 6, and the 2 8s. And the middle number here is 6. Now, once we've determined the quartiles, the IQR, interquartile range, is Q3 minus Q1. We take the 6 minus 3, and we get 3. So the middle 50% of our data will have a range of 3. From this, we can look at another graph, which is called a box plot. The box plot is made up of 5 numbers: the min, the Q1, the median, the Q3, and the max. So taking our data, again putting it in ascending order, what we're going to do is we're going to graph the 5 numbers. And what we have is over here we have the min, over here at the 8 we have the max. We're going to draw a line. We're going to draw fences at 3 and 6, which are our Q1s and Q3s, and a fence at our Q2 or our median. And we're going to draw a box. So this is called a box plot, sometimes referred to as a box and whisker. Now you'll notice that the reason we would do this is because it'll tell us the 25% quartiles. So from 1 to 3 is the lower quartile, from 3 to 5 is our second quartile, 5 to 6 is our third quartile, and finally our last quartile is from 6 to 8. So this over here represents 25% of our data. This portion represents another 25% of our data, and so on. Another type of spread is called the standard deviation. And the standard deviation determines how far the data is from the mean. Formula for it is S equals the square root of the sum of the x minus x bars squared divided by n minus 1. If S is small, the standard deviation is small, then the data is close to the mean. If the standard deviation is large, then the data is spread out from the mean. So let's take an example of our data. We know that the mean is 4.667. So what we did was we took each one of these x values and subtracted the mean. Notice we get negatives and positives. We're going to square these numbers and add them up, and we get 48. Using our formula, the numerator is going to be 48. Our denominator is going to be 9 minus 1 because there's 9 pieces of data. So we get the square root of 6, and we get 2.450 for the standard deviation. So this number is relatively small, so that means that our data is pretty close to our mean, which is 4.667. Now, if we square this standard deviation, this is called variance. So our variance in this example would be 6. All right, let's look at where we have a lot of data. Now, we could sit there and find the mean, standard deviation, and so forth, finding all these numbers. However, it'll take a long time. So what we can do is we can create a frequency table where we have our values, our x values, and then our frequency in the second column. So what we're saying here is that we have 124, 225s, 126, 531s, and so on. Now we want to find the mean, the standard deviation, Q1, the median, and Q3. So we're going to type this into our calculator. In L1 are going to be our x values, L2 are going to be our frequencies. We go to Stat Calc, option number 1. We have one variable. Even though we have two lists, we really only have one variable. The second column is our frequency. So we're going to type in 1 and then do one var stats of L1, comma L2. L2 tells me that that's a frequency. So we're going to get the following. We're going to get x bar equals 52.452. That's our mean. S of x is our standard deviation, so we get 18.1. N is 42. And then if you scroll down, you'll see your 5-number summary that'll make up your box plot. You have the min, 24, Q1, which is 36, median, which is 58, Q3, which is 72, and our max, which is 75. The other ones we'll talk about it at another time. So if you go to Stat Plot, scroll down to the type, and go to the 5th option, which is this option right here. For your X list, you're going to use L1. For your frequency, you're going to put L2. Hit Zoom 9, and you're going to see your box plot. Next, we're going to talk about an ogive, also known as a cumulative frequency plot. The way the cumulative frequency plot works is you have your X values. However, in the second column, you have your frequencies, but they're the cumulative frequencies. In other words, before we had 1, 24, 2, 25s. Well, now we have a 3 here. This 3 represents that there are 3 numbers that are 25 or less. The 4 represents that there are 4 pieces of data that are 26 or less. If we go down here to the 31, 31 represents there are 31 pieces of data that are 65 or less. What we're going to do is create a line graph. And notice on the y-axis we have percents. The reason we want to do percents is because this can tell us a lot in terms of where our data falls. In other words, if I want to find the median of our data, I can look at 50%, and the median would fall at this dot right here. So approximately at this dot, whatever this x value is, would be my median of all my data. I can also find the Q1, Q3, and other information. Now, in an ogive, it is a line graph that will always be increasing or flat at some point. However, the graph will never decrease because you're always accumulating more information, more data. To do this on the calculator, you're going to go to Stat Plot, turn on a plot, and go to this second option or type. For your X list, you have L1. For your Y list, you have L2, which is your cumulative frequencies. And then do zoom 9, and this is what your graph will look like. Next, we're going to talk about outliers. To determine if any of our data is considered an outlier, before we just had to look at a distribution graph like a histogram and see if there was anything that was out of the ordinary. Now what we're going to do is we're going to actually find it numerically. So there are two formulas that you need to consider. One of them is if you have any data that's above Q3 plus 1.5 IQR or below Q1 minus 1.5 IQR. Another formula that you can use is any data above X bar plus 2 standard deviations or below X bar minus 2 standard deviations. Let's take the following data to determine if we have any outliers. The data is already in ascending order, so what we're going to do is we're going to find Q3 and Q1. So Q1 turns out to be 3, Q3 turns out to be 6. So what we're going to do is find our IQR. So Q3 minus Q1 equals 6 minus 3, which is 3. Then using our formula, Q3 plus 1.5 IQR, we get 6 plus 1.5 times 3, which is 10.5. And then Q1 minus 1.5 IQR, which is 3 minus 1.5 times 3, which is negative 1.5. What we're trying to do is determine if there's any numbers above 10.5 or below negative 1.5. And it turns out we do have one number. The number 15 is above the 10.5. So this number 15 is considered an outlier. Now using the other formula, we have our data. We need to find our X bar, which is our mean, and our standard deviation. So plugging these numbers into the calculator, we get 5.444 for our mean, 4.15 for our standard deviation. So we're looking for a number that is above the mean plus 2 standard deviations, which is 13.74, or any numbers that are below the mean minus 2 standard deviations, which is negative 2.86. You'll notice that we do have a number, the number 15, which is above the 13.74. So that 15 is considered an outlier. So either one of these formulas is a valid formula to determine outliers. Turns out that one of your options on your calculator for box plots is one that's called a modified box plot, which will show any outliers. Under Stat Plot, if you go to Type, the fourth option, which is this one right here, is a modified box plot. And what it does, it finds or determines any outliers. So I have some data in my X list. My frequency is 1. I had a box plot created. And you'll notice that this dot here is considered an outlier because it's not part of this line. So this value is an outlier. And the formula that is being used is the IQR formula. Q3 plus 1.5 IQR and Q1 minus 1.5 IQR.